In this question here, we're not asked to find the entire inverse of this matrix A. We actually just want one of the entries of the inverse. And of course, we could just go ahead and find the inverse using traditional methods like row reduction algorithm. But we were introduced to a formula in this section which can be applied and does allow us to find one entry at a time. And so the formula that we're given for the inverse is that it is 1 over the determinant of A times the adjugate matrix A. So there's going to be a lot to unravel. So first of all, we have to know what the adjugate matrix of A is to be able to use this formula as it is. But there are some kind of really neat properties that maybe come from this if in a practical way we really wouldn't use this to find inverse. Like it's not super helpful to us to know this whole formula with how much unraveling needs to be done for it when we have other algorithms. But if you have a look at some of the other questions in this section, it kind of alludes to the ways that this formula is used in higher level mathematics, which is actually really cool. I've actually personally used it in a graduate level number theory course, for example. You're talking about the divisibility of some of the terms that show up as far as like prime divisibility. So it has its applications. Not really a ton of them in maybe anything you guys will do in the near future, but who knows if you end up in graduate level mathematics, you might see this pop up again. But so a little bit of unraveling. We've got this adjugate matrix here. So we have to go back and get the definition of that. So for a 3 by 3, it's going to be the transpose of all of those cofactors. So I'm just going to lump that all together, but you have all your cofactors. Instead of being CA12, the 1, 2 is going to go down here instead of reading across. And so then we get C21. And there probably should be commas in there. It's not 11, 21, etc. But hopefully you know that I'm just being a bit lazy. And so yes, remember this is the transpose of that cofactor matrix. And that's why the numbers aren't really written in the order that we would usually see them. And so for this question, we are specifically asking for the 2, 3 entry. And so what I'm going to do is go to the second row and the third column. So we are going to look for the entry that does correspond to this one here. So if I do want this 2, 3 entry, and why don't I just go ahead and call it A23, then what I'll know from this is that A23 is basically equal to that cofactor C32A divided by the determinant of A. So at any point in time here, we could have done the calculation for the determinant of A. Again, I'm not going to do it by hand on this video, but you can do it however you like to get the determinant of A is equal to 51. So not a great number. And then that cofactor, so remember how we get those. That's if you recall from the cofactor expansion. If I am trying to find this value, I would do it by basically finding the determinant of the matrix that we get when we eliminate the third row and the second column. So I don't know why I'm circling them. What I actually want to do is eliminate them. And so the resulting matrix is that 2 by 2. So the 1, 1, 3, and negative 1. And the determinant of A is 51. And so you can calculate that. It's 1 plus 3 is 4 over 51. And so this gets us just that single entry. Obviously, if I'd asked you to find the entire inverse, you'd have to find all of those cofactors for all 9 of them. And may or may not be easier than just going through and using the algorithm. I probably would say maybe one advantage to using the algorithm is that if you make mistakes in the algorithm, that ends up being like halfway through and it's hard to track and go back and fix your work. Whereas if you make mistakes here, it's likely just in individual calculations. So that might be more beneficial because it's easier to find.